now looking at question 5, trigonometry. 5.1, in the diagram below, T with the coordinates x and 15 is a point in the Cartesian plane such that OT is equals to 17 units. P with the coordinates -2 and a lies on OT. Here is point P. K is a point on the positive x-axis. Here is point K, and TOK, angle TOK is theta. Angle TOK is theta. Determine with the aid of the diagram the following. Alright, 5.1.1. We have our diagram, and on our diagram it is on the Cartesian plane. Once we work on the Cartesian plane, our ratios, sine, cosine and tangent, you need to remember that we have to define them in terms of x, y and r. Sine theta, y over r, cos theta, x over r, and tan theta, y over x. And we must also remember the theorem of Pythagoras in terms of x, y and r. X squared plus y squared is equals to r squared. Now looking at OT, if we are to construct a circle that is going to pass through point T, you will notice that OT is actually a radius. So looking at point T, we have x, we have y, which is 15, and our radius from the center to the circumference of the circle is given by 17. So even if the circle is not there, remember that you can always construct it. You don't need to construct it, just in your mind. Alright, determine the value of x. Now let's focus at point T. Looking at point T, we are having x and y. X is x, y is 15, and OT, which will be the radius, is 17. Therefore, let us make use of Pythagoras to find the value of x. X squared plus y squared is equals to r squared Pythagoras. X is x squared plus y is 15 squared is equals to our r is 17 all squared. Then x squared will be equals to 17 squared minus 15 squared will give us 64. Then taking the square root on both sides, x will be plus or minus 8. But now on the Cartesian plane, we can see that point T, it is in the second quadrant, and in the second quadrant the values of x are negative. Therefore x will be equals to -8. Now 5.1.2, we have to determine tan theta. Tan theta is equals to our ratios in terms of x, y and r. Tan theta is equals to y over x. What is y? Y is 15 over x. X is -8. Therefore tan theta will be equals to -15 over 8. Then 5.1.3, we have to determine cos of 180 degrees minus theta. Cos of 180 degrees minus theta. Here we must first apply the reductions. 180 minus theta, second quadrant. How is cosine in the second quadrant? It is negative. Therefore, cos of minus 180 degrees minus theta will reduce to negative cos theta, of which it will be equals to negative into, what is cos theta now? We are on the Cartesian plane. The ratio x, y, and r. Cos is x over r. X, negative 8, r, 17, which will be equals to negative 1 times negative 8 over 17, positive 8 over 17. Now 5.1.4 sine squared theta. Sine squared theta will be equals to, we'll first rewrite it as sine theta all squared will be equals to bracket squared. Inside the brackets we have sine theta. What is sine theta? Sine theta, y over r. Y is 15 over r is 17, which should be equals to 15 squared 225 divided by 17 squared 289. And 5.1.5, determine the value of a. Right, now let's focus on point P. Again, on point P we can construct what? A circle. Therefore, on that circle, it's clear that the radius is now what? OP. The distance from the center of the circle to the circumference of the circle. OP is the radius, and theta, KOP is equals to theta. Therefore, how can we now find the value of A? Point P is x and y. X and y, our ratios, we are talking about tan. And luckily, we have already calculated tan theta in 5.1.2. We know that our tan theta is negative 15 over 8. Therefore, we can say tan theta, now looking at OP, tan theta will be equals to y over x, y, point P, y is a divided by x, negative 2. But what is tan theta? Tan theta is negative 15 over 8 will be equals to a divided by negative 2. Now multiply both sides by negative 2. We get a is equals to 15 over 4. Right, now moving to exercise B. Simplify without using a calculator. Okay, now this will be equals to sine of 120 degrees times cos 210 degrees times tan 315 degrees times cos 27 degrees all divided by sine 63 degrees multiplied by cos 540 degrees. So we'll be applying our reduction formulas. So let us look at one ratio at a time. Sine 120 degrees, it is an angle in the second quadrant. Therefore, will be sine of, in the second quadrant, we have the formula 180 degrees minus theta. What must we subtract from 180 to get 120 is 60 degrees. Multiplied by cos 210. Cos of 210. 210 is an angle in the third quadrant. In the third quadrant, we have the formula 180 degrees plus theta. What must we add to 180 to get 210? We must add 30 degrees. Multiplied by tan of 315 is an angle in the fourth quadrant. In the fourth quadrant, we have the formula 360 degrees minus theta. And we must subtract 45 degrees from 360 to get 315. multiplied by cos 27 degrees is already an acute angle, and that acute angle is not a special angle. Let us leave it as it is, cos 27 degrees, all divided by sine 63 degrees. 63 degrees is an acute angle, and an acute angle that is not a special angle. Remember, in the numerator we also have a similar case, 27 being an acute angle, that is not an acute that is not a special angle. So now immediately you come across this type of a situation, check if you have one angle in the numerator and the other one in the denominator. Both angles are acute angles, but they are not special angles. Check if you add them together if you are not going to get 90 degrees. 27 plus 63 is 90 degrees. Therefore, we are dealing with core functions or core ratios. Therefore, sine 63 degrees is the same as cos 27 degrees multiplied by cos 540 degrees. Angles that are greater than 360 degrees, simply subtract multiples of 360 degrees until you get an angle that is between 0 degrees and 360 degrees. So 540 minus 360 gives us 180. Therefore, cos 540 is the same as cos 180 degrees. Addition and subtraction of 360 does not change the value of those ratio. Alright, equals to, now one ratio at a time. Sine of 180 degrees minus 60 degrees. 180 minus 60, second quadrant. In the second quadrant, the ratio sign is positive. Therefore, this will reduce to positive sine 60 degrees multiplied by the next ratio, cos of 180 degrees plus 30 degrees. 180 degrees plus 30 degrees, it is in the third quadrant. In the third quadrant, cosine is negative. Therefore, this will reduce to negative cos of 30 degrees multiplied by tan of 360 degrees minus 45 degrees. 360 degrees minus 45, it is in the fourth quadrant. In the fourth quadrant, tangent is negative tan 45 degrees, and 27 will cancel 27, all divided by cos of 180 degrees. Use your special angles. 180 degrees is part of the special angles from the unit circle. Therefore, cos 180 is just negative 1 equals to, now in the numerator, sine 60. 60 is a special angle. Sine 60 is going to give us root 3 over 2 multiplied by cos 30. Negative cos 30 will give us negative root 3 over 2 multiplied by negative tan 45 degrees will give us negative 1, all divided by negative 1. Negative 1 cancels negative 1. Root 3 over 2 multiplied by negative root 3 over 2 will be negative 3 over 4. Right, now moving to 5.3, we have to prove the identity. 1 over cos theta minus cos theta over 1 plus sin theta is equals to tan theta. So let us choose a side. Left hand side is equals to 1 over cos theta plus cos theta, all divided by 1 plus sin theta, and let's put 1 plus sin theta inside the brackets. Then we are adding the two fractions, so let us ensure that the denominators are the same. This will be equals to, we are going to take 1 over cos theta, we multiply it by 1, but what is the special one? The special one is 1 plus sine theta divided by 1 plus sine theta. It comes from the denominator of the second fraction, plus the second fraction cos theta divided by 1 plus sine theta. We also multiply it by 1. Our 1 is going to be cos theta divided by cos theta, which is the denominator of the first fraction. This is how we get the same denominators. Equals to, then 1 times 1 plus sine theta, 1 plus sine theta divided by cos theta times 1 plus sine theta, plus cos theta times cos theta, cos squared theta, all divided by 1 plus sine theta times cos theta. We have cos theta times 1 plus sine theta. Now our denominators are the same. Now that the denominators are the same, we say the denominator cos theta times 1 plus sine theta. Then we simply add the numerators, 1 plus sine theta plus cos squared theta. But now, as we simplify, what will be cos squared theta? Cos squared theta from the square identity. The square identity sine squared theta plus cos squared theta is equals to 1. Then making cos squared theta the subject of the formula, we get cos squared theta is equals to 1 minus sine squared theta. Therefore, we know that cos squared theta, it is the same as okay. Before we get there, let us first correct the sign here. We are having 1 over cos theta minus, so this is minus minus, so minus cos squared theta. Cos squared theta is 1 minus sine squared theta. Right. Of which it will be equals to, now in the numerator we have 1 plus sine theta minus 1 plus sine squared theta, all divided by cos theta multiplied by 1 plus sine theta. Then in the numerator 1 minus 1 is 0. Therefore this will be equals to, in the numerator we have a common factor, sine theta. Take sine theta out as a common factor and we'll be left with 1 plus sine theta, all divided by our denominator cos theta multiplied by 1 plus sine theta. 1 plus sine theta cancels 1 plus sine theta. What is sine theta divided by sine theta? Quotient identity, it is tan theta. Tan theta is equals to our right hand side. So that is how we prove the identity for question 5.3. And the last question, question 5.4, determine the general solution of 3 sine x is equals to 2 tan x. Okay, 3 sine x is equals to 2 tan x. So what we want is to isolate the trigonometric ratio and just have what sine of an angle, in this case sine x is equals to a number, cos x is equals to a number, or tan x is equals to a number. So let us simplify our equation. 3 sine x minus 2 tan x is equals to 0. Then 3 sine x minus 2 tan x is the same as sine x over cos x. The quotient identity equals to 0. Then let us get rid of that cos x in the denominator by multiplying throughout by cos x. 3 sine x times cos x, 3 sine x cos x minus 2 times sine x over cos x multiplied by cos x. It will be just minus 2 sine x equals to 0 multiplied by cos x is 0. Then on the left hand side, common factor sine x. Sine x is a common factor into, then we'll be left with 3 cos x minus 2 will be equals to 0. Now we're having a factor equals to 0, factors equals to 0, then we equate each factor to 0. Sine x is equals to 0, or 3 cos x minus 2 equals to 0. Then simplifying the second equation by isolating the trig ratio, we get cos x is equals to 2 over 3. So now for the general solutions. Let's start with first the equation sine x is equals to 0. For the equation sine x is equals to 0, what will be the general solution? Now remember the general solution for sine. If you are having sine theta is equals to a number, be it positive or negative, theta will be equals to sine inverse of a plus k times 360 degrees, or theta will be equals to 180 degrees minus sine inverse of a plus k times 360 degrees. That is how you find the general solutions if your ratio is sine. If a is positive, you substitute it as positive. If it is negative, you substitute it as negative. So applying that formula, sine x is equals to 0, we are going to get x is equals to sine inverse of 0 plus k times 360 degrees, or x is equals to 180 degrees minus sine inverse 0 plus k times 360 degrees. Therefore, x will be equals to sine inverse of 0 degrees plus k times 360 degrees, then on this equation x will be equals to 180 minus 0, 180 degrees, and we have plus k times 360 degrees. Then don't forget to indicate that k is an integer. Now taking the second equation, now for the equation cos x is equals to 2 over 3. For the equation cos x is equals to 2 over 3. Now, what is the formula that, or the method we need to apply when we are dealing with the ratio cosine? Remember that if cos theta is equals to a number a, be it positive or negative, then theta will be equals to plus or minus cos inverse of a plus k times 360 degrees. Therefore, using that method here for cos x is equals to 2 over 3, we get x is equals to plus or minus cos inverse of 2 over 3 plus k multiplied by 360 degrees. So now we are just going to split the plus and minus. So we'll have, or we can say x is equals to plus or minus, what is cos inverse of 2 over 3? Cos inverse of 2 over 3 gives us 48,19 rounded off to 2 decimal places, plus k times 360 degrees, where k is an integer. Therefore, we can split it. X is equals to positive 48,19 degrees plus k times 360 degrees, or x is equals to negative 48,19 degrees plus k multiplied by 360 degrees.